Write the expression x squared minus 6x plus 1 in this form here, where a and b are constants. In other words, we want to complete the square. So we're going to take half of the coefficient here, so negative 3, and we'll have x minus 3 squared. And remember that if we expand that, what you would get is x squared minus 6x, which is all good, but plus 9, and we only want plus 1. So what we need to do is take away the 9 and then add the 1. That 1, of course, just from here, which is x minus 3 all squared, take away 8. Hence write down the coordinates of the turning point of that graph. Well, we can read from here that the x-coordinate will be 3 and the y-coordinate would be negative 8. We're given that f of x is the square root of x, just for values of x greater than or equal to 0, which it has to be. We can't put a negative under the square root. And g of x is x plus 5, again for x greater than or equal to 0. Identify each of the following functions with one of the inverse of f, inverse of g, f of g, g of f, f squared, or g squared. So the square root of x plus 5 means that we must have done g first and then stuck the result into f. So that one is fg. X minus 5, well, the opposite of adding 5 is take 5 away. So that looks like it's going to be the inverse. X squared, well, that is going to be the inverse. So, sorry, that was g, wasn't it? So that one is the inverse for g. And then x squared, well, that's the inverse for square root. So that one is going to be the inverse of f. And finally, we have x plus 10. Well, if you do g, you add 5. And if you do g again, you add another 5. So in total, you've added 10. So that one there must be g squared.